Good morning, class. Today we're going to be learning about Coulomb's law. Coulomb's law states that the distance and strength of charge determines the strength of the bond. The equation for Coulomb's law is as follows. F coulombic is proportional to Q1 times Q2 divided by R squared.
What do those symbols mean?
F coulombic represents the energy of attraction or repulsion between charged particles. Can anyone tell me what this definition could also apply to? Yes. Is the answer ionization energy? Yes, that's absolutely correct. By definition, ionization energy is the energy needed to remove the outermost electron. The greater the ionization energy, the stronger the attraction, and the more energy needed to remove that electron. Now, what about that weird open-ended infinity sign in the middle there? That just means that one side of the equation is proportional to the other side. If one side increases, the other will increase proportionally. If you want to think about it in equation form, you can think of it as y equals kx, where k is a constant. The other side of the equation is fairly simple. Q1 represents the charge of an electron, Q2 represents the effective nuclear charge of protons in the nucleus, and R squared represents the distance between the charged particles. Any questions so far? The last thing we're going to talk about is effective nuclear charge. Effective nuclear charge is the strength of the pull of the nucleus on the valence electrons after subtracting the shielding effect of the core electrons. The equation for this is protons minus shielding/core electrons, which are any electrons except valence, the valence electrons, equals effective nuclear charge. Coulomb's law states that the distance and strength of charge determines the strength of the bond. Therefore, it's basically saying that the reason that valence electrons can get lost or gained or shared more easily is because there's more distance between them and the protons that are attracting them. Additionally, if the effective nuclear charge is lower, like bromine, the strength of charge will be lower, meaning that the strength of the bond will be lower overall. That just about wraps up our lesson for today. Thanks, guys!